Hey everyone, welcome to Learn, Earn, Grow with PG, the place where we simplify tech, supercharge skills, and level up your DevOps journey. I'm PG, your friendly DevOps engineer. Let's jump into today's topic. So, guys, in today's session, we are going to set up and configure a minimalist Kubernetes cluster. Yes, you heard that right. We are going to set up a small, little, cute Kubernetes cluster for our learning and testing purpose. So before we jump into the real hands-on, we need to understand what are the major difference between the traditional Kubernetes and the minimalist Kubernetes. So for your easy understanding, here I have listed few key points that you need to remember before picking which one is best for your daily task or for your workload. So let's start from the traditional Kubernetes cluster, what we call it as K8s. We all knew that Kubernetes is a master and slave architecture and it has multiple components. So the major components are a master component and a slave component, and within master I have um, HCD, API server, a kube scheduler, manager. So these are all the different components we have within master component, right? So which makes it even more heavier. And as I said, it is using HCD as a database externally to maintain all its informations in the form of a key value pair. It makes Kubernetes even more heavier. Because of all these extra components and the heavy one, the resource utilization of the traditional Kubernetes is much higher. At least it needs 2 plus GB of RAM to spin without any issue. So in what kind of real-time scenarios that you can stick to the traditional Kubernetes cluster, in the sense like if your application is a huge application with 50 plus 100 plus microservices put together, and it receives thousands and millions of traffic per second, and also it need to be highly available, and it has to do auto scaling based on the traffic, then we don't have any other choice. You need to stick to the traditional Kubernetes. Either it could be an self-managed Kubernetes cluster or a cloud-managed one like EKS, AKS, or GKS, right? And now we are jumping into the real concept of today's session, that is the minimalist Kubernetes. So what we fondly call as K3s. It is very lightweight. It was actually built by Rancher, a lightweight version of an fully blown the traditional Kubernetes. So it is actually designed for low resource environments like Raspberry Pi or edge devices or very small cloud VMs. Even you can spin up this minimalist Kubernetes cluster in your t2.micro machine. That is more than enough. Why? Because it has a single component, that is a single binary. It is not just like the traditional Kubernetes where it has multiple components. It has only one component, one binary. I guess it is less than 100 MB, I guess. Okay, so it has a single binary. It's super fast to install and gives you all the Kubernetes goodness with less bloat. And on top of that, it uses a SQLite as an database, which is a default one, which makes this particular minimalist Kubernetes even a lighter one. And with all these single binary and SQLite, the resource utilization of the minimalist Kubernetes is just 512 MB, which is good enough to spin up your cluster, and you can test your application in this cute little one. And also, setting up this Kubernetes cluster is a very simple task. Just by running 2 to 3 commands, you'll be able to bring up your cluster. But whereas in traditional Kubernetes, you need to follow a sequence of commands that you need to run in your VM to bring the traditional Kubernetes up and running. You have to generate a token, and that need to be copied into your master machine, where you need to configure both master and slave put together. So all these will make the traditional Kubernetes a complex one to set up and install, right? Fine. So now let's quickly jump into the real hands-on. As I said, setting up this minimalist Kubernetes is very easy, and also it requires an less resource. We are going to try this out with Ubuntu machine, Ubuntu 24.04, and look here, I'm going to choose instant type as t2.micro, and it provides one virtual core CPU and 1 GB of RAM. So as I said, it just require 512 MB of RAM to spin up this cluster, right? So we are going to choose the least free tier one that is being provided by Amazon. And I have all my key pairs ready. I'll stick to the default VPC and the default security group. I really don't want to create multiple security groups for this, and I'll go with the least memory that they provide, that is 8 GB. Okay, the volume. I'll spin up my machine. Okay, I guess my mission is almost there. Okay, let me give name to my mission as K3s. So as I already said, you can have this minimalist Kubernetes cluster for testing your applications in lower environments like dev, QA. So these kind of environments, you can just replicate it in the form of a minimalist cluster, and you can continue with your testing. And this minimalist Kubernetes cluster is not meant for UAT or any kind of an high load environments like production staging. You cannot use this. So this is just for learning and testing purpose, where you don't want to spend much of time in configuring the whole cluster. So in that case, you can go with this cluster. Let's wait for this mission to get initialized. Yes, it's almost there. Okay, I'll pick this public IP. I prefer using Mobextrum, and you guys can pick your own choice, git bash or putty, whatever. Even VS Code is well and good. I'll just re-edit my previous session with this new IP and the same key pair which I used for my testing purpose. I'll stick to the same key pair, and that's it. We are good to go. Let's try. Yes, it got connected. Guys, trust me, this is gonna be super easy. So let me switch to root user. Okay, so since this is my new server, let me update and upgrade my server, and it's gonna take a while. And in the meantime, like when to use an traditional Kubernetes cluster, as I've already said, if your application is an enterprise grade application with hundreds and thousands of microservices put together, and if your application needs an high availability and auto scaling that need to be in place to serve the traffic, you can go for a traditional Kubernetes cluster. So the main purpose of setting up this minimalist Kubernetes cluster is mainly for deploying it on a simple a small VMs or a Raspberry Pi or VMs that has a memory which is less than 1 GB. So in those cases, you can consider using the minimalist Kubernetes cluster. And running applications in edge locations or remote offices, yes, you can go for this. And also like doing a quick local development or and if you have started learning Kubernetes, about all the objects of the Kubernetes, and you want to give a try practicing all the hands-on, yes, you can go with this minimalist Kubernetes cluster, right? Fine. So my update and upgrade is almost done. And let me disable the swap memory here. Why? Because Kubernetes always likes predictable memory management. So this swap memory may mess the overall performance, and it may consume the extra resource from the underlying hardware, that is the T2 micro. So let's turn off the swap memory, and this is optional. Even turning it on, you can try testing this minimalist Kubernetes. Okay, so I've just disabled my swap memory, and now it's time to install our minimalist Kubernetes cluster, that is K3s, and along with that I'm disabling the traffic. So this particular command actually installs minimalist Kubernetes package into your T2 micro machine, and since we have added an extra flag that is -- disable traffic. Why? Because we are not using an ingress controller right now, right? I'm not going to run any kind of application that is going to be communicated to the outside world through HTTP or HTTPS protocol. So in that case, why it is should be enabled. So it is not required actually, right? So I'm just disabling traffic and installing my K3s package here, and it also saves memory on T2 micro if you turn off this traffic and the swap memory. I think it's almost done, and I need to check whether this is ready or not. Yes, my Kubernetes cluster is up and running. The minimalist Kubernetes cluster is up and running, and we are good to go. And let's check the pod status here. Okay. I'll check kubectl get nodes. Yeah, here we go. See, look at the IP address of this particular machine, and the status is ready. And this is our control plane and the master machine. See, this is similar to that of a minikube. Even minikube requires at least an T2 medium machine, right? So here for minimalist Kubernetes, you can always go for the T2 micro, which is more than sufficient. So this single machine serves as your master and as well as a slave. It's an exact replica of an minikube, right? And it is up and running. And now, and if you want to run all these kubectl commands in the form of an non-root user, you can run this particular command, because it is not advisable to perform an kubectl command as a root user, because you are giving some elevated permission that may trigger something, or something fishy may happen. So it is always better to run as a non-root user. To run kubectl as a non-root user, you need to run these commands. So this will alter the kubeconfig in such a way that even if you're running as a Ubuntu user or the customized user that got created during the time of your onboarding in your organization, obviously you can use your own username and perform all your kubectl commands. And that's the main reason. We really don't want to run everything with a sudo every time, right? So we copy the kubeconfig files to our users directory, and this gives us full control with just kubectl. You are not going to give sudo before each and every kubectl command, something like this, right? So that's the main reason. And finally, we'll try to pull all the pods that are running in this machine. So if I just give kubectl get pods, it says that there is no resource at all, which means we haven't created any custom pods. So in the default namespace, so what it does, it doesn't list any pods. And at the same time, if I want to pull all the core level pods, I can give an extra flag -a. Look here, core DNS, local path provisioners, and metric servers. All these are the Kubernetes core level pods which are up and running. 1/1 status, it is ready, right? It haven't restarted. So this is how you can set up your cluster. And if it requires, like if you want to try with running your own pod, let's try to give that a try as well here. So let me create a pod So this is going to be my custom pod. Okay, so my pod dot YAML, and let me, so this is an NGINX pod. Okay, NGINX pod. Okay, so my, yes, this is my pod definition file, kubectl apply -f and the pod definition file. It will create a pod. So now if I simply give kubectl get pods, see, it lists the pod which I created recently in the default namespace, and it takes almost like 10 to 15 seconds to be up and running. So let's give a second hit whether it is ready or not. See, now it is up and running. So all our minimalist Kubernetes cluster is ready for your learning purpose or any kind of a quick testing that you want to perform. Yes, you can go ahead with this. So yeah, that's it guys. Thank you very much. We'll catch up in next session with a different configuration.